morning, students. This is Dr.GVR Seshagiri Rao, Associate Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So, in this session, I would like to discuss about problem on riveted lap joint. So, riveted joints are classified into two types. Already you know, we have discussed in the previous sessions: lap joint and butt joint, single riveted lap joint and the double riveted lap joints. So, how to solve problem on these riveted the lap joints? So, today we will see. We will take one problem and then solution also we will discuss. So, here a given problem is a double riveted lap joint with zigzag riveting. Is given double riveted lap joint and riveting is to be designed for 13 mm thick plates. The thickness of the plates is 13 mm. Assume tensile stress 80 megapascal and shear 60 megapascal and sigma C 120 megapascal. And state how the joint will fail and find the efficiency of the joint. So already you know the failures of riveted joints and the strength of riveted joints and how to calculate the efficiency of the joint. We have seen in earlier sessions. But here he has asked for double riveted lap joint, that also in a zigzag riveting. So how the joint will fail? So which type of failure will occur? When it is designed for, it is subjected for 80 megapascal tensile and shear 60 and sigma C 120 megapascal. The dimensions are the thickness of the plate 13 mm. So now we will see the solution. First of all, write down the given data. Given data is here thickness is 13 mm and sigma T 80 and tau is 60 and you can convert into megapascal into Newton per mm square and compressive stress. First calculate diameter of the rivet. So here diameter of the rivet is not available. It has not given. So only thickness is given 13 mm. So that also greater than the 8 mm. So if the plate thickness is greater than 8 mm, the diameter of the rivet wall you can calculate by using Hunwin's formula. So this formula is called Hunwin's formula. D is equal to 6 root T. So T is here thickness of the plate. So whenever the given plate thickness of the plate up to 8 mm, okay, no problem, directly you can take the thickness. But in case of 13 mm and greater than 8 mm, that time the diameter is equal to 6 root T. So here take this formula and find out the diameter of the rivet. After that, the second step is pitch of rivet. Calculate the pitch of the rivet. Pitch also here not available. For double riveted lap joint with zigzag, so already we have seen in the previous session figure. These are two rivets per pitch length. So one is N is equal to 2. So that is double riveted. So that the number of rivets here are 2. The tearing resistance of the plate is, you can calculate by using this empirical relation. This is P minus D into T. So this is tearing area across the rivets. P minus D into T multiply with sigma T. So here pitch value we don't know, but tearing resistance the value also you don't know. So in terms of in terms of pitch, you will get the tearing resistance of the plate. So the final value is P minus 23 multiplied with 1040 newtons in terms of P only. So here unknown is the pitch. And shearing resistance of the rivet. Similarly, apply the shearing resistance formula. PS is equal to number of rivets and shear area multiply with shear stress. There are 2 rivets in a single shear. So that's why need to multiply with 2. Next one is from equations 1 and 2. From equations 1 and 2, so equate these two, you will get pitch of the rivet. The shearing resistance of the rivet and the tearing resistance of the rivet. Whenever the pitch value is not available, whenever the diameter is not given, so then you should equate these two shear resistance equations, you will get the pitch value. The maximum pitch is given as per BS standards C into T plus 41.28 mm. So remember this one. So now third one is distance between the rows of rivets. So what is the distance between the rows of rivets for zigzag riveting? So this is zigzag riveting. For zigzag riveting, the distance between the rows, the empirical relation is 0.33 times of pitch plus 0.67 times of D. Pitch already calculated, and D also calculated. So substitute these two values, you will get distance between the rows of rivets. And then margin. So margin value, the margin value 1 m is equal to 1.5 times of D. To avoid failures, tear failures, already we have discussed in the failures of a riveted joint. You should take the margin value is 1.5 times of D to avoid failure for safe joint. Clear. So 1.5 times of your substitute diameter. So we'll get the margin value 35 mm. So failure of the joint. So which type of failure will occur in this given joint? So let us find the tearing resistance of the plate. And next, shearing resistance and then crushing resistance of the rivets. So calculate the shearing resistance of the tearing resistance of the plate. P minus D into T into sigma T. So substitute the above values in this equation, you will get tearing resistance. Similarly, calculate shearing. Shearing also will get. Finally, the crushing of the rivets, crushing stress, crushing resistance will get. So now, take the least of the above values. So it means the least of tearing resistance of the plate, and then shearing resistance of the plate, and the shearing crushing stress of the rivets. So which one value is the minimum least value? So here least is 49864. So that is in the shearing case, shearing resistance. Hence the joint will fail due to shearing of the rivets. You can say, so the joint is fail due to the shear failure. Clear? So like that, you have to solve this problem, this type of problem. Clear? So, and then calculate the efficiency of the joint. The efficiency of the joint, you know that the strength of the unriveted or solid plate. So P into T into sigma T. P is pitch value and T is the thickness of the plate, and sigma T is tensile stress. So now apply the efficiency of the joint formula. The efficiency of the joint is least of PT, and that is a tensile stress, the tearing resistance, and shearing resistance, and crushing resistance. It gives strength of joint. So strength of joint upon solid plate strength, you will get efficiency. So efficiency means efficiency of the riveted joint is a ratio of strength of joint to the strength of the unriveted or solid plate, that is P. So we calculated P value. So the substitute the P value and PS value in this relation, you will get efficiency 67.5%. So So like this, how to solve this type of problems. Thank you. So these are the references.
Like, share and subscribe. Hit the bell icon for more updates.